I'm Anil Kumar sharing with you a very fundamental question on equivalent polynomials. The question is, how many minimum points should you check to prove that two polynomials of degree n are equivalent? You can always pause the video, answer the question, and then look into my suggestions. Now let's derive at this result by taking a few examples. So let's say we start with a linear function. Okay, so if I have a linear function, in that case we could write equation as y equals to mx plus b. Now that results into a straight line, let's say kind of like this. By taking any 2 points on the line, we can define a line, right? So let us say these points are x1, y1 and x2, y2. Then we know slope m is y2 minus y1 divided by x2 minus x1, right? So we get a unique slope. Once we get the slope, we could use any one of these points to get to the equation. So the important criteria to define a line is 2 points, right? So we have 2 points. So in case 2 points match, then the lines are exactly same, right? If 1 point is matching, we could have a line like this. 1 point matching, right? A kind of like this. However, if both the points are same, you can only draw a single line. Do you see that? You can only draw a single line. So for a linear function, we need how many points? 2 points to be sure that they are equivalent. Do you get the idea? Right? Now let's talk about a quadratic function, degree 2. So this linear is degree 1, now degree 2. As you know about parabolas, let me sketch one here. Let's say we have a degree 2 function which results into a parabola. Now if we have 2 points common, in that case, do we have equivalent parabolas? No, we don't. We could draw many with these 2 points common, right? So they are not equivalent. They are not equivalent. However, if we define the third point, we say, well, also match the third point. Then you can draw only one parabola. Is it okay? So generally, you could have an equation saying y equals to a times x minus x1 times x minus x2, for example. Now, a value is specific about the third point. So if the third point is same, you get same a, perfect. If third point is different, you get different a. So for non-equivalent, you need 3 points minimum. So 2 points or 3 points, this is, we are talking about points required to be checked for non-equivalent functions, right? So, okay. We are restricting ourselves to polynomials. That's correct. So if I extend this to cubic, then can you tell me where n is equals to 3, how many points should we check for the two to be equivalent functions? You got it. We need to check 3 plus 1 points, right? So you need to check 4 points. That is 3 plus 1. Do you see that? And that gives us our result, that for a degree n polynomial, we need to check how many points? We need to check n plus 1 points. We need to check n plus 1 points to show that they are non-equivalent or they are equivalent, right? So if all the points match, n plus 1 points match, then they are equivalent, right? So points required to be checked for I should say actually equivalent functions is n plus 1 matching, right? So n plus 1 match gives us equivalent function. So you have to check at least n plus 1 points to decide. If they match, then we have equivalent function. So what we could write here is we need to match n plus 1 points to show equivalent polynomials, where n is the degree, right? So I hope that is absolutely clear. If any one of them doesn't match, then they are non-equivalent. I hope you like it and understand the basic concept. Based on this, we could have few questions, right? You can also post questions and feel free to share my videos with your friends and subscribe to them. Thank you and all the best.